Hello and welcome to section 10.4, which is on perimeters and areas of similar figures. Theorem 10.7, perimeter and areas of similar figures. It says if the scale factor of two similar figures is A divided by B, then the ratio of their perimeters is also A over B, and the ratio of their areas is A squared over B squared. So for example here, two similar polygons have corresponding side ratios of 5 to 7. What is the ratio? And I want you to do larger to smaller of their perimeters. What is the ratio also larger to smaller of their areas? Okay, there's really not much to this one. So if I'm starting out with 5 to 7 for the side ratios, and then it says what is the ratio of their perimeters, well, if you go back up here and look at that statement, it's the same thing, except this says they want it larger to smaller. So the answer would be 7 to 5 for the first question. And it says what is the ratio larger to smaller of their areas. Again, they want the big one first. And what this says right here is you square the 7, you get 49. You square the 5 and you get 25. There is your answer to the second question. You just have to make sure that you pay attention to how they want it. Big to small, small to big, which way. My next example, the scale factor of two similar parallelograms is 3 to 4. The area of the larger parallelogram is 96 square inches. What is the area of the smaller parallelogram? So one thing that we know is our original scale factor is 3/4, which means their areas have to be squared. So it would be 9 to 16 for their area. That is not one of the answers to the question, but I have to use that to find the answer. So I'm going to set up a proportion to do this. So if my scale factor is 9 to 16, and I know that the larger parallelogram has an area of 96, I can just put an x in here and figure out what I need. So 16x equals 96 times 9 is 864, and then I just go ahead and divide by 16. So my x is 54, and because it's area, it'll be 54 square inches. So again, using the idea of the scale factor and what happens to it when you have the area, I can go ahead and solve that. My last example, so the areas of two similar rectangles are 1875 and 135. What is the ratio of their perimeters? And it doesn't necessarily say small to big, big to small. If it doesn't say, normally you do small to big. So it's 135 over 1875, and normally you're going to reduce that. And so if I divide by 5, I get 27 over 375. And then I can reduce that again by 3. It would be 9 over 125. I would probably take that as an answer. They want you to go even a step further, and they're saying, well, can't you square root this and get 3 over, to square root the 125, I'd have to break it down to 25 and 5, and so then it would be 5 square root 5 for the final answer. Like I said, I would probably just accept the 9 over 125. It's the same thing, okay? But they do want it in simplest terms for the answer, so bring that knowledge with you, and we will talk about it more the next time I see you. Have a good night.